Okay, now so we'll talk about one very related topic, which is the ionic product of water. We have talked about the weak acids and weak bases, and we said that the acid is, when we talked about the acids, we took a symbol HA for acid, and for base it is MOH. And we said that the A and the M are the acid and the base radical that are bounded to the H and OH to form acids and bases. But there is one special case, which is H and OH, which is water. So in case of water, you have hydrogen and hydronium ions, which is not acid and not base, it's water. And in case of HOH and the water, you can apply the same thing that we mentioned before, that this will dissociate in water to give H plus and OH minus. And this is going to be special, as I mentioned, because in the cases that we mentioned in the previous video, we had either this or this, but we didn't have both of them. Or you can write it in another way, that H2O, 2H2O will dissociate into H3O plus OH minus. And this is another way to write it. So in this case, I know from the balance of the equation, this is 2 to 1 to 1. So the ratio of these two is 1 to 1. And this is something that I can apply the law of mass action to. So I can put K of W, which is for water. It's going to be the product, which is H3O plus multiplied by the OH minus. And again, for water, we never put the values of water in the law of mass action. So in this case, this equation, this this K is called the ionic product of water. This is the ionic product. It's like the the acid dissociation constant, the base dissociation constants we mentioned before. This is the ionic product of water. And water is a very special case, as I mentioned before, because it is a very widely used liquid, and it's used almost in every everyday life. So that's why the K for water is well known. So the K for water equals 10 to the minus 14 at 25 degrees Celsius, which means that if temperature changes, this K will change. It's 10 to the minus 14. I'm not sure if it's clear here or not, but it's 10 to the minus 14, which is this 10 to the minus 14. Okay. So again, I'm gonna apply the law of mass action in more details. I know that the K of water equals 10 to the minus 14. Okay, and I know that the K of water equals to the concentration of OH minus multiplied by the concentration of H3O plus. And I know that these two have the same values from the stoichiometry of the dissociation of water. So I can say that the concentration of OH ions equals the concentration of H3O plus ions equals to square root of the K, which is 10 to the minus 7. To make life easier, and because we know that all the values of the concentrations that we deal with are very small, it's 10 to the minus something. So we can just take this number, and instead of saying 10 to the minus 7, so I can say only 7. And when I say 7, I understand that it is 10 to the minus 7. And to do this, we will take or we developed a new variable, or a new parameter, which is called the pH and the pOH. The most famous one is the pH, of course. It's a very well-known thing. So the pH is negative log of the concentration of H positive. Why we did that? Because when you do the negative log of 10 to the minus 7. From mathematics, we know that the if we have log of 10 to the something, then we will take the power outside. So it's gonna be negative 7 log 10, and log 10 is 1. This will cancel out, and then it's gonna be 7. So what we did when we put the negative log is that we took only the negative of the power of the 10. This is for pure water. So pure water is totally neutral. So we have developed a new scale, and of course, before I skip this point, if the concentration of hydrogen ions is higher, the pH would be lower, because it's, for instance, it's higher, it's 10 to the minus 3, then the pH will be equal to 3. If it's 10 to the minus 2, then the pH is going to be 2. So as the concentration of hydrogen ions increase, the pH will decrease. And as the pH decreases, it is more acidic, because it has, or it's richer in the hydrogen ions, and the vice versa. So that's why we developed this scale, which is a very famous scale for the acids and bases. We have the neutral in the middle at 7, and the 0 is the most acidic solutions would have the pH of 0, and the most basic solution will have a pH of 14. So this is the pH scale, and again, it started from the ionic product of water, as we mentioned in the beginning of this video. I'll stop here, and we'll continue the next video, inshallah.